Alright, in this video, I'm going to just do a few more examples of how to use integration by parts to find integrals. In the last video, I just gave an introduction to the idea, and let me just for the sake of review, let's remember what integration by parts is. So if I have an integral of something that looks like, we're going to call it u times v prime. So you basically have two functions that are multiplied. One of them we're going to consider u, and the other one we're going to consider v prime. Then the way to find that antiderivative, if we work the product rule in reverse, is u of x times v of x minus the integral of u prime v. Okay, so here's another example. Here I'm going to take a definite integral, so the integral from 1 to 4, or the area under the curve, from the square root of x times the natural log of x. Okay, so again, the question is, the first thing we need to do is we need to identify what u is and what v prime is. All right, now we could let u be square root of x, but then that would leave v prime to be natural log. And we don't really know what the antiderivative of natural log is, but we do know its derivative, all right? So that in itself is one way to, now actually we will actually find the antiderivative of natural log using integration by parts, but it doesn't have a simple, antiderivative that it's just a function, we know it, it's a little bit more complicated than that. So that could be one clue. So let's let u equal natural log of x, because u prime is something we know, right? That's just 1 over x. And we'll let v equal the square root of x, which is the same as x to the 1/2. That's not a hard one to find the antiderivative of, right? That's the power rule in reverse, so we add 1 to the exponent. That gives us 3/2, divide by the new exponent. That gives us 2/3 x to the 3/2. So let's just try this and see how it works out. Okay, so this is going to be u times v. So I have natural log of x times 2/3 x to the 3/2. And since this is a definite integral, that part of it is done, right? There's no more integration to do, so we can just evaluate that at the endpoints of our interval, minus the integral from 1 to 4 of u prime times v. So that's these being multiplied, 1 over x times 2/3 x to the 3/2 dx. So I'd like to simplify this integrand here before we go any further. So I'll just rewrite this for right now. 2/3 x to the 3/2, 1 to 4. And so the 2/3 can come out, and I'm taking 1 over x times x to the 3/2. So that's basically taking x to the 3/2 and dividing by x. So that ultimately gives me 2/3 integral from 1 to 4 of x to the 1/2 dx, which actually is just square root of x, right? Okay, let's evaluate over here. So if I put in 4, I get natural log of 4 times 2/3 4 to the 3/2 minus natural log of 1 2/3 1 to the 3/2. So that's just going to be a number. We'll simplify that. This we've already done once, right? We saw x to the 1/2. We took it. That's what the antiderivative of x to the 1/2 is. So I've got minus 2/3 times 2/3 x to the 3/2, and this we will evaluate. All right. Now here, I'm going to move this around so the number ends up out front, but 4 to the 3/2, well, first we can take the square root of 4, that's 2, raised to the 3rd power is 8, times 2/3, that's 16/3, times the natural log of 4, natural log of 1 is 0, so we're done with this. Now, minus, and I'm going to have 4/9, right, and then I'm going to do, 4 to the 3/2 minus 1 to the 3/2, then 16/3 natural log of 4. Well, we've already done 4 to the 3 halves, right? Square root of 4 is 2, cubed is 8, 1 to any power is 1. So that's 8 minus 1, which is 7. And 7 times 4 is 28. So minus 28 over 9. So not a pretty number, but that, if we could simplify that on our calculators, get it down to a decimal, that would be the area under the curve of this function from 1 to 4. Okay, let's do another example. So in this example, we're going to find the integral of the natural log of x over x dx. And the question is, how do we start here?
I have no idea.
Well, you might notice that this, well, you may or may not notice, but we can rewrite this as the integral of natural log of x times 1 over x dx. So notice we have a function and its derivative in here. So that suggests that we should use U-Substitution, all right, and not integration by parts. So let's go ahead and do that substitution. Since I already know kind of how the story ends, I know that we're going to use integration by parts after we do the substitution. So I want to reserve U for integration by parts. So I'm going to let t equal natural log of x, because then I get that dt equals 1 over x dx. So that's covered by my dt. So this is going to be t, this is going to be dt. So now my new improved integral is this. Now this is actually one that we can also use integration by parts. There's a little bit of a trick here. So the trick is to recognize that natural log of t is the same as 1 times natural log of t, and we can think of 1 as a function, right? It's just a horizontal line, but it is a function. Again here though, we need to figure out what u and v prime are. All right. Now in this case, it doesn't make any sense to call natural log v prime, because then we have to find the antiderivative, but that's the problem we're trying to figure out. So that would kind of keep us in, infinite circles. So let's let v prime equal 1, and we'll let u equal natural log of t, because we know what u prime is, right? That's 1 over t. And if I do the antiderivative of 1, the derivative of what equals 1, well, that's just going to be t. All right? So now what I end up with is u times v, or t times the natural log of t, minus the integral of u prime times v here. So that's 1 over t times t dt. But 1 over t times t is just 1. So I'm left with t natural log of t minus the integral of 1 dt. We've already done that, right? So I have t natural log of t minus t. Don't forget, this is an antiderivative, so we're looking at plus c. Now we need to plug back in all of our, remember we started off with something in terms of x, and we're looking, because this is an antiderivative, we're looking for a function of x that I can take the derivative of and get this crazy function over here. So we need to put everything back in. So this just leaves us with natural log of x times the natural log of x minus the natural log of x plus c's. Is that enough natural logs for you? Okay, so this is what we get, just basically taking this substitution, putting natural log of x back in for t. All right, so the trick here was to recognize that we needed to do a substitution first, and then we reduced it to something we could use integration by parts on. All right, one more example that I would like to do involves this integral, where we have the integral of x squared e to the x dx. All right, so again, if you look at this, we don't really know how to find the antiderivative of that directly. We might try some different things, but trust me, we're going to do integration by parts. There's no substitution. Remember, for substitution, what you're looking for is a function and its derivative somehow kind of hidden or wrapped up in the whole thing. But e to the x and x squared, they don't look anything like each other. They're not really related in terms of functions and derivatives or antiderivatives. So let's just, let's say we really don't know. We need to figure out what u and what v prime are going to be, so we can use our formula u times v minus the integral of u prime times v. So let's just look at what happens if we let u equal e to the x and v prime equal to x squared. So then u prime is e to the x, v is x cubed over 3. All right, so that wasn't so bad. So then this would give us u times v, which is x cubed over 3 times e to the x minus u prime, the integral of u prime times v. So that would be x cubed over 3 e to the x dx. We can bring the 1/3 out, so we get x cubed over 3 e to the x minus 1/3 integral x cubed e to the x dx. Well, how do we do that? That looks an awful lot like this one, so we could try the same approach, right? So we can do integration by parts on this. Let u equal e to the x, so that u prime is still e to the x. We'll let v prime equal x cubed, and then that means v is the antiderivative of x cubed, which is 1/4 x to the 4th. Now notice, now when I do u prime times v, I'm going to have x to the 4th times e to the x. So this seems to be getting worse and not better, right? We started off with an x squared, now we have an x cubed. Next time we do integration by parts, we're going to end up with x to the 4th. So this is one way to think about how to choose u and v prime, is we want to be progressing towards something that we know how to find the antiderivative of here. So let's switch these around and see what happens. So down here, let's let u equal x squared, and we'll let v prime equal e to the x, so that u prime equals 2x, and v equals, well, the antiderivative of e to the x is e to the x. So now, for the antiderivative of x squared e to the x, u times v, so we get back our x squared e to the x, minus u prime times v, or 2x e to the x dx. All right, well, we still don't have something we know how to find the antiderivative or the integral of, but notice that we're better now, right? We've gone from originally having an x squared, now we're down to having an x. So let's see what we can do with this. We have x squared e to the x minus, I'm going to bring this 2 out, integral x e to the x dx. Yep, let's use integration by parts on that. All right, so if we let u equal x, v prime equal e to the x, then u prime is 1, v is e to the x. Notice now that we're going to get u prime times v, we're just going to get e to the x. That's something we can do. So we're making progress. All right, let's see. X squared e to the x minus 2 times this whole thing. So u times v, that's x, e to the x, and then we're going to subtract the integral of u prime times v, so that's just going to give me e to the x dx. All right, that's, well, let me just rewrite it. X squared e to the x minus 2 times x e to the x minus e to the x. Remember, we are going to have a plus c on here because we're finding a general antiderivative, not a definite integral. Let's distribute and try to simplify here a little bit. X squared e to the x minus 2x e to the x, and then the minus 2 times the negative e to the x, that's plus 2 e to the x plus c. Notice that each of these terms has an e to the x, so we could simplify a little bit further if we wanted to. X squared minus 2x plus 2 plus c. So sometimes there's a couple things to note here. One is that we want to choose u and v prime wisely. And sometimes that's just going to be a matter of experience. You know, you go through this a couple times and you see what's happening. So you want to notice what's happening here. Is what you're getting over here for your u prime v, is that progressing towards something that you could find the antiderivative of if you can't find it immediately, or is it getting worse, going from x squared, x cubed, x to the fourth? The other thing is that sometimes you may have to apply integration by parts more than once to kind of break this down to something that, you know, ultimately we got down to this integral of e to the x. That's something that we knew how to do. So those are just a couple tips as you try some of these integrals using integration by parts.